G'day everybody, where's Wally here? Well, today let's have a look what Gigantor has done again and made another great big mistake. Well, perhaps not. You look at the title here, he's got Flat Earth Truth and Proof Revealed with Euclidean Geometry, and he's probably right this time. He probably has revealed the truth, probably just not the truth he wanted to reveal though. So in summary, what he started off with here is a big bridge in America, one over near the Statue of Liberty. And it's got two big towers. They're not poles, Nick, they're towers. They're huge. And these things are just beautifully vertical. But that also means because they're a kilometre or more apart, they're just not quite parallel. But Nick thinks that that doesn't matter. Well, it probably doesn't matter all that much, but I think his logical fallacy is that he's saying this distance is so small that it doesn't matter, therefore it doesn't exist. And that's clearly wrong. It clearly does exist, and for a very good reason, Nick, because the Earth is a sphere. His fallacy goes a bit like this. If I'm in a plane flying at 47,000 feet, now it's got to descend down to a runway at 1,000 feet. I want that plane to stop at exactly at 1,000 feet, not 10 feet above the runway, certainly not 10 feet below the runway. I mean, it's only a small distance, and that small distance means a lot to me, being alive or dead.
Hello, Flat Earth researchers, debaters and debunkers. This is a photograph of the Verrazano Bridge in New York, and it's a good example of how spherical geometry has been used in the design of the bridge, based on the assumption that we must do so to incorporate some assumed curvature of being on a spherical Earth. But we'll see that it really doesn't matter whether you use spherical geometry or planar geometry. The difference is so negligible that...
No, Nick, it's small, not negligible. If it was able to be ignored, the engineers would have ignored it. It's taken into account because at some level it matters and it needs to be taken into account.
When it comes to the practical usage and application of this design in the real world, there really is no difference between the two geometries. This is a diagram of the Verrazano Bridge, and we can see here how, of course, it's not to scale, but the idea is that although the poles are almost vertical.
No, Nick, stop trying to be tricky. Those towers are vertical. There's no almost about it. The only almost here is the level water under the bridge. It's almost flat.
Use spherical or non-Euclidean geometry, then that is the foundation of all the other calculations that are made from it. So it will all work out mathematically to be correct and true. So let's put aside all the confusing terminology and really dumb this down to its fundamental level for those of us who apparently suffer from dyscalculia and an inability to understand mathematics. And this, of course, is what gives mathematicians some feeling of superiority, because they have some fluency in mathematics and the terminology that's used to describe it. They feel that they have the right to claim that they have better knowledge than those of us who might not be so proficient in mathematics.
But dumbing this down for dyscalculia sufferers. Well, Wolfie's going to like that one, isn't he? Look, basically, I'm going to skip a lot of this because it's just Nick going off and reading from Wikipedia on Euclidean, non-Euclidean, hyperbolic geometry, whatever it is. He does a good job of reading.
Whatever represents perspective. This now looks like a three-dimensional image that has depth, because what we kind of see in our eyes is what we know would be parallel lines coming from these points around the edges and appearing to converge where they meet at this point on the line. So now we have this changing of the parallel postulate. But if for example, you took a ruler, a 30 centimeter ruler, and it's flat, and you bend that ruler, it is still 30 centimeters long. Okay, so that the physical distance doesn't change.
Okay, Nick, take a 30 centimetre long ruler and bend it, and the distance doesn't change. You sure about that? But it does, Nick. Take a steel ruler that's like 1 millimetre thick, 300 millimetres long. Bend it in half like a C or a U shape, okay? Yeah? Now, the distance around the middle is, say, 300 millimetres. The radius of the curvature here at this time is half a circle, so it's 95.4929 millimetres. And what's the distance on the outside surface, I hear you ask? Well, the radius is 1 millimetre more, so it's now 96.4929. Multiply that by pi, and you now got 303.14 millimetres, which is 3.1415 millimetres longer around the outside of the ruler than the inside. So, Nick, you're incorrect. The ruler stretches. It's not the same.
Whatever. But of course, what we have now when it comes to using a coordinate system on the Earth is a projection of spherical geometry. Spherical geometry is used as the start point.
These parallel lines of latitude, yes, finally you're getting it right, Nick. They never meet or converge.
And then you have these parallel lines which appear to converge at some...
What are you talking about, Nicholas? You talking about longitude lines? Well, they're not parallel. Man, your faithful's going to call you on that blunder.
Arbitrary or predetermined point, basically the poles. Of course, those poles did not exist on a sphere until there was a point designated for them.
And why were the two poles picked? Not randomly, as you're trying to suggest. No, it's picked because they're special. They're the centres of axial rotation, Nick. So go to the South Pole and look up. Look up in the winter and you will see the sky rotating neatly around it. Have a look at this.
Whatever. Why do we have this spherical geometry used for the coordinate system? Well, of course, the shape or the coordinate system for the Earth was determined from looking up at the sky, at the stars.
Yes, so simple, isn't it, Nick? Just look up at the stars.
Is now one of the poles, the South Pole or the North Pole, okay?
Two poles, yeah?
You're not flying above a spherical Earth. You're certainly not flying above a spinning spherical Earth.
Oh, spinning. Oh, that word is a dog whistle to the faithful who believe. No, the correct way to describe this is flying above a slowly rotating globe. It's not so appealing to the faithful though, is it, Nick?
You are flying above a level plane. You fly straight and level. And you have a horizon that is at eye level. It's not a bulge of curvature, just as this is not a bulge of curvature in front of us. The horizon is at eye level because it is a flat surface, and that's how flat surfaces appear. But they appear to converge. So that appearance of convergence has been applied to create this globe Earth.
So stand at the equator on the globe and see those two latitude lines on your left and your right, the 20-degree ones? They're parallel, Nick. They never meet. They're just like train tracks around and around the globe.
Whatever. An abstract mathematical model that has no basis in our physical reality. None whatsoever.
Except that it is exactly based on the physical reality, Mr. Backwards.
You can look at the water underneath the bridge. It doesn't bulge or curve, and if there is a curve, the water will flow down it. The real physics of where we live is obvious. Water flows down curves. There is no curve in front of us, and there is no curve side to side. And defies all our practical applications on or above the Earth.
Oh, hang on there, big fella. you're saying exactly the opposite of what you started out saying. You just finished telling us that it doesn't matter whether it's Euclidean or spherical geometry, it'll work out. Now, when you're in dog whistle section of your talk, you have to say all these things that the faithful need to hear. Tell them it'll work out with no physics being broken. That's what you said at the start. Here, have a listen.
When it comes to the practical usage and application of this design in the real world, there really is no difference between the two geometries. Imagine that the Earth is a sphere and use non-Euclidean geometry to describe living on a sphere. They will dogmatically stick to that, and they will then... And that is why perspective is the imaginary curve.
Well, expect to hear that line from flatties everywhere in future. Perspective is the imaginary curve. Imagine perspective is the curve.
Rather than using Euclidean geometry to measure the size and shape of the rotating sphere. People looked up into the sky to determine the size and shape and dimensions of the Earth.
Okay, so if you like that, how about you click and share and subscribe and be the first to get in on the next fun little adventure into destroying the flat Earth. Now, while you're doing that, I'm going to literally destroy this little thing here.